So horizontal asymptotes, let me write the definition basically. Maybe that will be better thing. So a horizontal line like y, you know, the equation for horizontal lines are y equal to a number, is a horizontal asymptote for f of x if either one of these things is true. Either L as x goes to negative infinity of that function is equal to number b, or limit of f of x as x goes to plus infinity is equal to that number b. In other words, to find horizontal asymptotes, we need to find limit of the function as x goes to negative infinity or positive infinity, and positive in both of them, and see which one gives you a number. If both of them gives you numbers, y equal to those numbers are horizontal asymptotes. So in this case, we are trying to find limit of f of x. Let me write plus infinity for now. So what happens here is that, okay, I have a rational, an irrational function in the numerator. As x goes to plus. We know the trick for these kind of functions. You have to factor out the highest power from the numerator and the denominator. So limit of, in the numerator, there is this square root. I will factor first highest power there. The highest power is x to the power 6. So I factor out x to the power 6. 1 minus 3 over x to the power 4 plus 2 over x to the power 5. And in the denominator, I factor out x cubed, so it will be 1 plus 1 over x cubed as x goes to plus. Then I try to separate this root. So we know that if I have root AB, that is root A, root B, providing that A and B are positive numbers. So from there, you can see that I have root of x to the power 6, 1 minus 3 over x4 plus 2 over x to the power 5 over x cubed 1 plus 1 over x cubed. Now, I have x to the power 6. This guy is same thing as x cubed squared. And you see, when you have something square under the square root, the absolute value of that comes out. So what I have here, limit of x cubed plus absolute value of x root 1 minus 3 over x squared plus 2 over x5. There is power cubed there over x cubed 1 plus 1 over x cubed. And this is as x goes to plus infinity. By the way, so far I haven't used anything of x going to plus infinity or minus infinity. Indeed, if this is either plus infinity or minus infinity, I will do the same thing. I will factor out the highest powers of this guy. So up to this point, everything will go exactly same way. This is where the plus infinity limit and minus infinity limit are going to go two different ways. Why? Because of this absolute value of x. So let me then separate these two cases. Limit of x cubed plus absolute value of x cubed times 1 minus 3 over x4 plus 2 over x5 over x cubed 1 plus 1 over x cubed. as x goes to plus infinity. Why I should separate? Because you see, as x goes to plus infinity, the numbers I'm working with, so as x goes to plus infinity, my numbers are going to be big, large positive numbers, or easily you can say that these are going to be positive numbers, yes? And when you have positive number, its cube is also positive number. And then from there, you can see that absolute value of x cubed is going to be itself. Absolute value of any positive number is that number itself. So here, the next step, I can get rid of absolute value. So it will be x cubed 1 minus 3 over x4 plus 2 over x5. Now, this is where we have something to do with the highest power of the numerator. I can factor out x cubed in the numerator, and I will get 1 plus root of 1 minus 3 over x4 plus 2 over x5 over x cubed 1 plus 1 over x cubed as x goes to plus infinity. And as you can see here now, I can factor this guy and that guy. I mean, cancel those numbers, and I can get down to a limit after cancellation to this limit. Now, I know that if limit at infinity exists, I can apply the rules, the limit rules and limit laws, and that will give me root 1 plus root 1 minus 0 plus 0. These guys will approach to 0. These guys will approach to 0. And in the denominator, I will have 1 plus 0. So that is 1 plus root 1 over 1, and that is 2. Limit of the function as x approaches to plus infinity is the number. Right from there, y equals to 2 is a horizontal asymptote. Is that all? Well, I have to check the other side. And when it comes to the other side, again, I will try to repeat everything as it is there. Copy and then paste. So first thing is that, okay, now we are going to negative infinity. Everything is negative infinity, negative infinity, negative infinity, negative infinity. The only difference appears here that when x goes to negative infinity, x is going to be a negative number, yes? And when you have a negative number, you find the cube of that, it is going to be negative number. That means that absolute value of x cubed is going to be negative x cubed. So here, that's where it shows the difference. So negative appears here, negative appears here, negative appears here. The rest of the work that I did will repeat for this guy as well. And what we will have here is this is that, this is that, and I need to now make this one. 1 minus root 1 is 1 minus 1. So I have 0 over 1, which is 0. The left limit, as x approach to negative infinity, also the limit of the function exists. It is a number, and from there I can conclude that y equal to 0 is another horizontal asymptote. So every function can have at most 2 horizontal asymptote, and this guy is one of the cases which has 2 horizontal asymptotes. One y equal to 2, and the other one y equal to 0.